Hello, my dear students. Welcome back to one more lecture on econometrics. In last lecture, we have discussed the concept of multicollinearity, okay, and its consequences or its types, less than multicollinearity and perfect multicollinearity, and what's the issue with these two types of multicollinearity, okay. And we have also seen some of the other consequences of multicollinearity, especially the problems with hypothesis testing and the problem with this uh, t ratios and and with variance. Okay, so today what I'm going to discuss with you is how or what are the how we can understand is there is a problem of multicollinearity. Okay, then how we can detect it, how we can find it, okay, and if there is if there is a multicollinearity issues, then what are the things that we can use to remove this multicollinearity, okay. So that is the issue, that's the highlights of the today's classes, okay. So before going to that, let me discuss an example, okay. So there's a research which was published by Mroz. In this research, he is basically going to test, or he has tested the sensitivity of an empirical model of married women's hours of works to economic and statistical assumptions. Okay, so basically, in this, what he has done, he has studied about the married women's hours of works and how these hours of works of this married woman are related to some of the some of its determinants. Okay, and he has published this work in the Journal of Econometrica. And when he published this article, he just giving some of the problems that he has encountered when he was analyzing these issues. Okay, so for this purpose, he has taken around 428 sample. He has basically collected the data from 753 movements. Okay, married women, but only 428 people or married women were going for works. Okay, so he selected 428 samples. Okay, based on their work status in 1975. So for studying this issue, he has collected the data and variable for he has collected the data for many variables. Okay, number of kids under age 60. How many kids are there for this woman who are under age 16? Number of kids between 6 and 18 age. Then total years of schooling, wages she is getting. Okay. Then what is the husband work status and hours of works? Okay. Then husband's age, husband's schooling, husband's wage, family income, then federal marginal tax, parents' years of schooling, unemployment status in the country, okay, and her experience. So for determining or for finding the average hours of average women's hours of works, that married women's hours of works are depends on these factors. Okay, but when you see this data, we can assume that or we can hypothesize that there will be certain collinearities. Okay, wife age and husband age, there will be a collinearity. Okay, then wife income, husband income, family income, both will have a collinearity. Okay, because husband income and wife income together is the family income. Okay, most of the for the most of the peoples. Okay, then married woman years of schooling and parent schooling will also related. Okay, similarly the age and experience will also related. Okay, so when we are doing this kind of regressions, many variables are seems to be highly correlated. Okay, so let us see how this is. Okay, let me take an example, the same examples. Okay, so let me take the raw data. Yes. Oh my God. Yeah. So look at this data. This is for the first woman. Okay. She has worked around 1610 hours in 1975. That means 1610 hours in 1975. In 1975, she has one kid under 6 age and no kid between 6 and 18. Her age was 32. Education status was 12. Wage was getting 3.34. Then husband hours of works was 2,700 see 2,708. The husband age was 34. Husband education was 12. Husband wage was 4. Then family income was 16 point something. Okay. Then the marginal tax was 0.72. Then mother education was 12, father education was 7 years, unemployment in the country was 5, and experience was 14 years. Okay, so this is the data he has collected. Then what we do, let me do a regression. Go to data analysis, regression. This will be our dependent variables, and this will be our independent variable. Okay, the label is there. Okay, now you look at what is happening to this model. Okay, actually I am getting very huge coefficients. Okay, but look at many coefficients are not significant. Okay, this is not significant, this is not significant. Okay, these are not significant, then this is not significant. Okay, then this is not significant. Okay, so in this many coefficients are not significant. Okay, and similarly if you look at this r square value, it is still very high, it is 0.58. Okay, so what will be the reason for this? Why we are getting many coefficients are insignificant? Because there may be certain collinearities. Okay, then how we can find whether there is collinearities or not? There are many methods. Okay, so let us back to our models. In this model, as I told you, many variables are seems to be related, or we can expect certain kind of nonlinearity or collinearity between these variables. Okay, yes. Then the major issue with this multicollinearity is the t ratio or t statistics will be insignificant, but the r square value will be very high. Okay, so this is a contradiction in this hypothesis or the significant testing. If all the t ratios are significant, then only the R square should be very high. Okay, but in the case of multicollinearity, even though the T ratios are insignificant or T stats are insignificant, the R square will show very high. Okay, so for showing that, let me take an example. Let me take an hypothetical example. Okay, so this is an example. Expenditure is a function of income and wealth. Okay, expenditure is a function of income and wealth. What I am going to do here, I will run many regression like C is a function of income and wealth. Okay, then second, C is a function of Y alone. C is a function of wealth alone. Then I will do wealth is a function of Y. Let us see how this will change. Okay, first let us take expenditure as dependent variable and these two are independent variables. Okay, so I have done a regression. Look at this value. Okay, this is not significant, this is also not significant. T stars are not significant. Okay, that's why p values are also not less than 0.05. But you look at this value, r square is around 0.96. Okay, it says that 96% of the total variations in expenditures are determined by the income and wealth, but income and wealth are not significant. Okay, now what I have done is I have removed this wealth. Expenditure is a function of income alone. Okay, now what happened, you look at income coefficients are 14.24 and it is significant too. Sorry, income coefficient is 0.5 and T stat is very high 14 and it is significant, and we are getting a 0.962. Okay, and when we remove the one variable from the equations, R square is not changing but T stat starts changing. What does it mean? That means if we remove the wealth variable, still 96% of the total variations in expenditures are explained by this income. Now you change the wealth, change the income to wealth. Okay, still you look at the equation, P stats are significant, P values are also significant, then still the R square is 0.95 something. It's close to 0.96. There's a marginal decrease. Okay, and when you do the regression Y on W, that means income is a function of wealth. Here I am taking two independent variables and one independent variable as the dependent and another as the independent. Okay, you look at this value, it is highly significant. And look at this R square, it is 0.9979 something. What does it mean? Y is a function of wealth. Income is basically a function of wealth. Okay, so any variations in income is fully explained by the variations in wealth. That means whenever your wealth varies, your income varies. And if you take the last one, wealth as a function of income, here also T stat is very significant, and look at this R square, it is also 0.9979. Okay, that means income and wealth, in both cases changes in these variables are better explained by the changes in the other variables. That means changes in the wealth are explained by the income and changes in the incomes are explained by the wealth. Okay, it means that these two variables are highly collinear or highly correlated. Okay, Then if you look at this correlation between these two values, how we can find out the correlation is equal to CORR correlation, and this is the first and this is the second. You look at the correlation, it is 0.9986. Okay, so this income and wealth are highlighted. That's why we are getting this kind of a results. Okay, yes. Now, what are the reasons for the multicollinearity? Okay, and why we are getting this multicollinearity? Okay, there are four different reasons for multicollinearity. First one, the data collection method. Okay, it means that if we are taking sampling over a limited range of values taken by the regressors in the populations. Okay, if we are taking the sample, if our sample size is small, then we can expect certain relationship in our independent variables. Okay, so the data should be very high. That means the data sample should be very high in order to uh, safeguard from the multicollinearity issues. Okay, second issue is constraints in the model or constraint in the population being sampled. Okay, in certain cases there we will have a constraint. Okay, so look at this example. Electricity consumption is a function of income and house size. Okay, electricity consumption in our household is a function of income and the house size. Okay, and what is the constraint here? Family with the higher income will always have the larger home. Okay, higher the income level, higher will be the size of the house. Okay, higher the size of house, then we can infer that this family will have the higher incomes. Okay, so income and house size will be automatically related. Okay, so this is the model constraint. We cannot remove one variables. Okay, because if you remove electricity consumption is a function of house size only, then we are ignoring the income. Okay, and if we cannot say that electricity consumption on the basis of income. Okay, so we need both variables, but when we include both variable, there is a possibility of collinearity. Okay, this is the constraint in the model. And third problem is model specification. This tells us that if we are using the polynomial term in the regression. Okay, as you know that in certain cases we have to use the polynomial model. For example, if you are measuring the average cost curve is u-shaped. In order to get this u-shape, we need to give the polynomial model. Okay, so for example, research and development cost is a function of size of the market or size of the firm and size of the firm square. Okay, whenever the firm size increases, the R&D expenditure will fall fast and then it will rise. Okay, so that means the R&D cost and family size are positively related. Sorry, U-shaped relation is there. Okay, for this kind of an issue, when we are giving a polynomial model in our equations, it says that one variable, if one variable is 2, then next will be 4. Okay, so the second variable will be exactly the multiple of the first variables. So, okay, so that's why there will be an issue of multicollinearity. Then the last one is the overdetermined models. What is this overdetermined model? This tells us that if the explanatory variable are greater than the number of parameters to no, greater than the samples. Okay, if our sample is less and we have to estimate more and more variables. Okay, independent variables are there are large number of independent variables, but we are having only less number of samples. Okay, so this is the overdetermined models. Okay, and this kind of models are exist in this medical research. Okay, so in medical research, if there are a new disease, okay, so for checking this the disease and its determinant factors, many patients are not available, and for one patient they have to check many factors, many variables. Okay, so in such cases we are having a few variables and a limited samples, so our model will be overdetermined. Okay, so if there's an overdetermined model, then there is a possibility of multicollinearity. Okay, then what are the symptoms of multicollinearity? That means how we can understand there is a problem of multicollinearity. Okay, there is no need to calculate the correlation between all these independent variables. By looking at certain statistics, you can tell that there is a multicollinearity. Okay, first issue or first symptom: independent variables considered very critical in explaining the models are not statistically significant according to the test. Okay, so we are considering that, for example, uh, quantity demanded is a function of price. Then there are other factors. Okay, but the critical factor is price. But when you do a model, this price variable is not statistically significant. Okay, similarly, when you are doing consumption function, consumption is male depends on income, and there are other factors. You are taking income, wealth, then family size, area of living, then all other factors are significant except income. Still there is a suspect, you can suspect that there is a possibility of collinearity or multicollinearity. Okay, second one, high R square. Okay, high significant F test, F value, but T stats are not significant. Okay, so this is the most important symptom of multicollinearity. If you look at this your data, your R square is very high, your F stat is also significant, but T stats are insignificant. Then you can suspect that there is a problem of multicollinearity. Okay, and third factor is parameters estimates drastically change in its values. Okay, and values are become statistically insignificant when excluding some independent variables from the regressions. Okay, so there are many regression in your many independent variable in your regressions. Then if you remove one or two regression or one of two independent variable from the model, okay, your parameters are drastically changing. Okay, and significance of the variables are changing its pattern. That means those variables are significant, they are not significant, and those variables they were significant in the last time, they are not significant now. Okay, so when you change the one variable, the model in its results are drastically changing. Then you can suspect that there is a possibility of multicollinearity. Okay, then how we can find out the multicollinearity? How we can detect the multicollinearity? Okay, the first one is, as I told you, look at the R square value. If it is exceed 0.8, but if your T stats are not significant, that means if your T stats is below 0, below 2, below plus 2 or below minus 2, okay, then there is a multicollinearity issue. If your R square exceeds 0.8 and T stats are below 2, okay, 2 means the critical value of the T statistics, okay, at the point of 0.05. Okay, and second method is you find out the correlation matrix. Okay, and in there are certain correlation or there are certain variable they are highly correlated. Okay, that means exceed 0.5, then we can assume that there is a correlation. Okay, so in our earlier cases, we had income variable, we have wealth variables, and if you find out the correlation between this income and wealth, if it is above the 0.5, then we can assume that, or we can conclude that there is an issue of collinearity between these two variables. Okay, and third method is examining the partial correlations. Okay, so in a regression of y on x2, x3, x4, okay, then what you have to do, you find out the r square between 1, okay, and 2, 3, 4 is very high. What means by this r square 1.234? Okay, here what I'm doing is r square between one variable and 2, 3, 4 variable are constant. Okay, so it means that your one variable is y. Okay, then all other variable are constant. Okay, this r square is very high, but the r square between 1, 2, keeping 3, 4 as constant, r square between 1, 3, keeping 2, 4 as constant, r square between 1, 4, keeping 2, 3 as constant. Okay, and you compare these correlation coefficients. Okay, the first r square is very high, but all other remaining r squares are very low. Then we have to suggest that the variable x2, x3 and x4 are highly correlated. Okay, so what you have to do first, you run a regression on y as dependent variable, then x2, x3, x4 are independent variable. Okay, then you find out the r square. Second, what you have to do, you regress y on x2. Okay, then third, regress y on x3. Then fourth, regress y on x4. Then find out the r square, and the first r square is very high and the remaining three r squares are very low. Then we have to say that these variables are x1, x2, x2, x3, x4 are highly related. Okay, yes. Third one or fourth one is run a auxiliary regressions. Okay, what does mean by auxiliary regressions? Regress each independent variable on remaining independent variables. Okay, and compute r square and ri square. What is r square and ri square? R square is the, suppose if you have a regression like consumption is a function of income and wealth, so c is a function of income and w, or y and w. Okay, so what you have to do, first you run a regression like consumption is a as dependent variable, then income and wealth as independent variable, then you find out the r square. Okay, that is your r square. The next, take two independent variable. Okay, wealth as a function of income, this is what is called auxiliary regression. Okay, then if your auxiliary regression r square are greater than the actual r square, then there is a problem of multicollinearity exists. Okay, then you can also check the variance inflation factor VIF. Okay, if VIF is equal to 1, then multicollinearity is completely absent. Okay, whenever the VIF is greater than 1, okay, then the multicollinearity issue is there. Then if it is very close to 0, then there is a high multicollinearity issues. Okay, yes. Now if there is a multicollinearity issues, then how we can remedy it? If there is a multicollinearity issues and if we are ignoring this issue, then there is a problem with OLS. Okay, OLS assumption is violated, then the result we are getting from this OLS will not be significant, or will not be, we cannot believe the regression. Okay, then how we can remedy it? There are certain methods. First method is do nothing. Okay, we don't need to do anything, because if the objective is only predictions, okay, then the objective of our model is only to forecast or predictions, okay, then you don't need to do anything, because multicollinearity is essentially a data deficiency problems, and we don't have any choice over the data availables. So what you have to do, you increase the sample size, okay. So multicollinearity is essentially a sample phenomenon, okay, or it's called micronumerosity, okay. It is that multicollinearity is essentially a sample phenomenon, and we don't have a choice over it, okay. So you don't need to do anything, because if your objective is prediction, okay. Second one, if you are having cross section data, okay, then you pool this cross section data with time series data, you combine both this data, okay, then your sample size will be increased, then we can remove this multicollinearity issues, okay. And third one, drop a variable that is highly collinear. Suppose in your example, if you are having wealth and income as independent variable, you remove one variables, okay. But still there is an issue with this. If you remove one variable, then it will lead to specification bias or specification problems, okay. And fourth one is you transform the variable, okay. What's transformation? We have a data on consumption, expenditure, income and wealth, okay. Then multicollinearity is mainly because of the reason that income and wealth both are moving in the same direction, okay. So you transform these two variables in such a way that, okay, both variables are not explicitly including in our model, but their effects are there without losing the effects, okay. You convert both variable as one variable, or you create an index, something like that, okay. Then you remove one variables, but you should not remove the effects, okay. And the effects should be there, but you have to remove one variables, okay. The last one is you can take the first difference. What is mean by first difference? Look at this data. Yt is equal to beta 1, beta 2, beta 3, beta x3 u, okay. First difference means yt, take the first difference, that means yt minus 1, okay, current value minus previous value, okay. Then x2 minus x2t minus 1, x3 minus x3t minus 1. That is what that we are just subtracting the previous values, okay, from the current values. So it will be change in yt is equal to beta 1 plus beta 2 change in xt plus beta 2 change in xt3 minus plus u, okay. So here we are taking the changes between the current values and previous values, okay. And if you take this kind of issue, if you take this value like this, then we can remove the multicollinearity problem up to a certain extent, okay. Then the most crucial method to remove this multicollinearity is the method of principal component analysis and the method of factor analysis, okay. So these two methods are most powerful methods, okay. So I'm not going to discuss the details, because it is a very complex methods, okay. And last one is the coefficient of variance decompositions, okay. So these are all certain methods used to remedy the issue of this multicollinearity, okay. So with this we have completed the portion of multicollinearity. In this chapter, in this portion, we discussed what is multicollinearity, what is this issues, and how we can find out there is a multicollinearity or not, what's the consequences, what are the symptoms, okay. Then what are the detection methods, and how we can remedy these issues, okay. Yes, thank you.